stuff. Yeah, I don't like to do this here.
Değerli katılımcılar,
Distinguished participants
değerli misafirler,
and
Türkiye
guests,
Kurulu tarafından kongresi
this is the 7th technical session of the Turkish Wind Energy Congress. I'd like to thank all our participants and the audience for being with us. This session is about, or is titled, Turbine Manufacturers and New Technologies. So, even though we don't have any local made turbines in Turkey, we still have lots of experience both in our country and also in the world, the wind power sector, and this is an important session in which we're going to share information with regard to the turbine manufacturers and new technologies in the wind energy sector. So I'd like to thank all our speakers, and our first speaker will be Mr. Fatih Yazataş. He is the head of department in the Ministry of Energy and is the head of department of the General Directorate of Renewable Energy in the ministry. And he graduated from Fırat University Electrical Engineering Department, and he's in a very important position in a very significant directorate of the Ministry of Energy. Our second speaker will be Andreas Beyer. Representing the Nordex company here, is a senior product manager, and I think it's very important for us to listen to his experience from the Nordex and also other experiences. Another distinguished participant is Yunus Işık. Also, he is the sales manager of the Enercon company, which is very prominent. I'm sure he's going to share a lot of important things with us as well. And our final speaker will be Mahir Tosun, sales manager of Siemens. So, both in this sector, we're going to hear from people who are actively taking part in the sector, who are actively working in the company, and we also have companies, and we also have people coming from the state. So we hope that's going to be a lot of experience and information shared. I don't want I don't want any of our speakers to exceed 15 minutes. We'll have 15 minutes for each of our speakers. Then we'll have the Q&A session, and hopefully we'll finish the session in time. Before passing the floor to our speakers, I would like to express my key items or key ideas that I have about this subject. In 2005, with the inaction of this law, in the previous session, our moderator was Soner Aksoy, and also I'd like to thank him for his contributions. It's a very dynamic sector, and sometimes the legislations that have been enacted need to be updated. I became a deputy in 2007, and I'm serving my second term after being re-elected in 2011. And in 2010, the law with regard to the Renewable Energy Sources Act, by number 6294, identifying the incentive prices and also the durations
gerekli düzenlemeler yapıldı. Dönem
were regulated, and we actually warned people that
7.3 sentin
the 7.3 cent
düşen garanti
guarantee price for kilowatt hour is inadequate, we said. Because
tarihten bu yana bakıyoruz. O kanun 2010'da çıktı.
when we look at 4 years that elapsed,
Bu kanun
we see that it's not sufficient. Because in 2011,
yönündeki
we had an agreement with our commission that this price would not really open up the field for investors in the sector. So there was a suggestion of amendment in the legislation. One was to change this incentive pricing and increasing this incentive number for $8 per cent for hydro, 10 for wind, 12 for geothermal, and 15 for biomass, and $15 for solar plants were the guarantee figures that we suggested, so that the sector would feel much more secure about the investors. And secondly, the subsidy or incentive for the local manufacturers were limited to 5 years. So that doesn't attract the investors. We had to have it up to 10 years. And also, the first application was limited to 600 megawatts for solar plant, and we also offered to remove this limitation. And also, this suggestion of law in 2011 is still not being taken into account by the parliament. So it's been more than 3 years. And while enacting a law, if you get the ideas of all the stakeholders and you enact a very good law, you definitely open the field up for the future, open the field up for the sector in the long-term future. But if you bring about a change in a law or in a legislation very quickly and in a very rushed manner, then you obviously don't go anywhere. There are many laws waiting to be enacted, or many legislation waiting to be developed or amended, and it's really difficult to get the chance to fix them all. So I now can say that when we look at the complaints coming from the sector, one of the main complaints so far has been the guarantee prices are not up to the standards required by the power that's being generated. So I'd like to ask you this question. For 1 kilowatt hour, do we have anyone here selling that at that price? No. If you have identified 7.3 cents for the state, and if the market is revolving around 12 or 13 cents, then nobody will give you any offers. Yes, the technology is evolving, the prices are going down. These are very important for the beginning, obviously. I don't reject that. But when we look at the practice, if we are going to reach an installed capacity of 20,000 megawatts of wind power, when you deduct 3.5 that we have today, it means that every single year till 2023 we need to erect wind power plants that will generate electricity up to the 3.5 or 3,500 megawatts every year. If we can say that we can establish this without a problem, there's no need to discuss that. However, the problem we face is a problem that awaits a solution, and that's the pricing issue. Secondly, we have very valuable investors here. What the investor looks for is obviously the political sustainability is key, but it's not the first thing. The first thing is safety. The second thing is profitability. And thirdly, the democratical climate. And fourthly, the political and economic sustainability. So
konuşulmaması lazım.
We shouldn't really talk about a security problem with regard to this country.
Biliyorum ve şahit olduğum ve
I know and I have witnessed that today in some provinces, some companies have made a decision to invest in those cities, but
tamamlayacak bir fırsatı
they do not have the opportunity to complete the establishment of the wind power plant or the hydro plant. Obviously, these concerns need to be eradicated. The other important issue is
bakanlıklarla Enerji ve Tabii Kaynaklar Bakanlığı arasında
there should be a bridge of coordination managed between the Ministry of Energy and other ministries. I've seen in Germany that the wind turbines are established in forest areas, for example, and the birds are not affected negatively. Or if we say that this is going to be a problem in Turkey, for example, in the chat reports or in historical site reports, this obviously results from the lack of coordination between the ministries. Obviously, a common ground needs to be found. Lastly, I'd like to mention that today we have our distinguished participants. I'd like to tell you that for facilities under 1 megawatt per hour, if that's the capacity, then there's no need to be licensed. But there is no company in the global economy that produces this. So we need to change it as one unit for wind and also in the solar plant and others. We should increase this level. If we don't do this, we're going to have lots of small plants without any licenses, without any badges, which are going to propose big problems for the competition of the market. And also, there should obviously there's no difference of bureaucracy between people who carry this job out with a license or without a license. So both types of people who get or who want to run a power plant do almost or go through the almost same procedures except the licensing. So obviously these items need to be discussed in a legal manner, and also our bureaucrats here and obviously the politicians here need to contribute to this. Also, the representatives of the sector and us need to come together, and obviously then we need to add all the information we can add to sort out these problems. If we don't do this, if we don't collaborate all together, we need the energy. We always demand the energy, and obviously as the population goes, as the growth goes on, Turkey cannot stagnate. So if we can't encourage or give incentives to these investors today, then we can obviously say that we can't really evade the pressures of the natural gas and petroleum lobby. So obviously, even if Mr. Minister doesn't really have anything to do with this subject, I have witnessed that the minister has given different proposals compared to what has been agreed on the commission. So we came together and we discussed that this shouldn't be the case. The party members have agreed, and if there's disintegration, then obviously this law will not come forward, and that's how we made it. We understood that the sector representatives or natural gas or petroleum lobby wants an order that will block this sector. So these are our resources, we need to take it into account. If we can't present the chance to the investor, this investor will leave this country and go somewhere else, or we have to import the energy which can be produced by the investors here, and we obviously consume energy in a more expensive way, which shouldn't really happen. So for manufacturing of turbines, even if that is the title, I believe that this session will be very important. We have very distinguished presenters and participants here. So the floor is theirs now for the next 60 minutes. And I wish you a very fruitful Congress and a session. And I hope that this Congress will bring about a change and good developments for Turkey. And I'd like to thank all the people who have taken part in this meeting once more.
Sayın Başkanımdan,
Now,
Daire Başkanımızdan başlayalım.
we'll start with Fatih, with the head of department. Thank you. Thank you, Mr. Moderator. If you want to give some additional information, you can, apart from introduction. Distinguished participants, before I start my speech, I'd like to extend my deepest regards. I'll talk about new technologies on the side of the state. When we look at where we have come to from 2003 to 2013, our electricity consumption and also the installed capacity has almost double-folded, as you see the figures on the screen. And also, the renewable energy installed capacity was about 12,640 megawatts, while in 2013 it's gone up to 25,596 megawatts. And also, when we look at the national greenhouse gas emission inventory, we see that our total greenhouse gas emission was about 300 million tons of carbon dioxide, while in 2012 this figure reached a level of almost 440 million ton carbon dioxide. So our emissions keep increasing. When we look at the R&D and innovation projects, we had signed a protocol with the TWEC, and with this protocol we now want to prioritize the generation and utility of the local resources and indigenous resources, also increasing competition in the sector and also strengthening the university industry collaborations and also run projects in due course. So when we look at the projects that we keep going on, one of them is the MILRES, the Milli Rüzgar Turbini, the National Wind Turbine Project. So we call it MILRES. In this MILRES project, obviously our target is to devise all the subsystems of a turbine and also test the substructure in Turkey, infrastructure in Turkey. The main aim of the project is to organize the required substructure, infrastructure for a wind industry which will be competitive and on world standard, which totally belongs to Turkey. Sorry, Fatih. Have you now established this turbine? Okay, I'll show you in the pictures in the next slide. In the second phase, we want to establish or develop a 2.5 megawatt turbine prototype. So obviously the rakes, hydraulic hardware, elevators and couplings on other wings and generators and other machines and towers will all be devised locally and nationally, have all been devised locally. And these are the pictures from the project. The production of the wings have been completed at the end of last month, actually last week, and it was formed in Istanbul. The generator was completed in June 28 last year, and this is the SCADA screen of the turbine. These are the main equipment regarding the tower. So on the right side, we have a picture from the on-site, and the basic construction has been completed in the October 31st, 2013. And the mounting will also start very soon, and after the test we'll expect our windmill to start turning. Another important project is the RITM project. So forecasting and evaluating the electrical power generated from wind. So when we look at the market, in the PME markets, we see that the wind powers or the generated wind powers will have positive or negative values, and then obviously the sales being done on the market price is key. So when we look at the wind plants, the forecasting the generation is obviously key, and the RITM project is obviously playing a key role with that regard, giving us a technical infrastructure. The RITM project takes the meteorological data from the current wind power plants, and obviously through the monitors allocated to the centers of the transformations of the plants, we can then evaluate and forecast the electricity to be generated from each wind plant for the next 48 hours. So when we look at the change in legislation, all the wind turbines and wind power plants are now due to this law, are now under this law. So also you can follow our development from the www.rhythm.go.tr. So we have some graphs coming from the rhythm. If you look at the bottom right, we see the generated electricity and also estimated electricity, and the estimations are pretty close, as you see. We also have other projects that have just started that we've collaborated with TWEC. So the MILTES is the National Thermal Power Plant Technology Development and Localization Project. Also, we have the National Sulfur Denalization Project. We also have the MILHES, the National Hydroelectric Plant System Development Project, National Solar Energy Development Project, MILGES, and LED and OLED are also important subject for us. There's about 7 million street lamps and about 4 million kilowatts per hour have been consumed. So obviously, how can we improve this situation was the question we asked before starting this project, and we target to achieve a 40% of energy saving, and this will obviously bring many changes as for technology and also the savings side. Obviously, I'd like to talk about hydrogen as well. Now we're carrying the Hydrogen Research Center from Istanbul to Ankara, and within this process we signed collaboration protocols with 14 universities, and we keep working on hydrogen. And in this center, after 2005, the vehicles and cars that work on the hydrogen energy are now almost ready to go out in traffic. We see hydrogen and wind together abroad. This example taken from Germany shows that when the energy demand is low, with the use of electrolysis, the hydrogen is uncovered in water, and then energy can be stored in hydrogen format. And obviously this hydrogen gas can be given to the natural gas pipelines, and with TÜBİTAK we are still in touch in terms of developing new projects with regard to this. Lastly, I would like to talk about the legislation that we are now still preparing. We have taken into account the ideas of the related authorities, but obviously we now have green certificates and legislation for the green certificates. What we target is the green certificates actually certificate that the electrical energy that has been consumed and generated are produced or manufactured through renewable energy sources. So, to give an example, a wind power can sell electricity in the electricity market, but if they do it in a certificated system, the consumers will see that the electricity they consume is actually licensed. And in law 6446, this was added as Article 7 to the legislation that was already in place, and that's why we're preparing this new legislation, which you can see on our website. And we reached out to all the authorities that are obviously players, and we obviously would like to get the opinions of the participants and also audience as well. And thank you for your patience, and I hope to see you in the Q&A session later. Thank you, Fatih. He talked about what the General Director of Renewable Energy is really doing, and I'd like to thank all our colleagues who took part in this. And my son, who's an industrial engineer, is also working in this directorate, so maybe I'll favor them towards the question and answer phase. Anyway, Kidding aside, our second speaker is Andreas Beyer from the company Nordex, and he will obviously enlighten us with his information and knowledge that he has. Thank you. The floor is yours.
Yes, thank you very much, Mr. Moderator. Ladies and gentlemen, welcome and thanks for staying with us during the late day, the last session. Today I would like to talk about, in this session, about turbine manufacturers and new technologies, about Nordex and the success factors that are vital for market success, also for Turkey. Basically, Nordex is seen as a turbine manufacturer. However, Nordex has a very wide value chain. Nordex has also business units that takes care after project development, securing land rights, building up wind parks and selling those to large investors, deriving a lot of know-how and experience which facilitates also the other business units. Certainly Nordex is delivering turbines, is providing civil works as well as electrical infrastructure, the installation and commissioning and the handover to service for a lifetime support. So all in all, you can see Nordex is a strong and a very competent partner for the wind industry also in Turkey. The products that Nordex is currently offering into the wind market globally consists of a mature and evolutionary development started in 2000 as a multi-megawatt wind turbines, starting with an N80 2500 kilowatt turbine, which was the very first globally serial multi-megawatt turbine that was installed in Europe. Ever since, Nordex is following an evolutionary approach coming from generation alpha to beta to gamma, deriving models like the N90, N100 and N117, which are well known to the Turkish market, establishing a global fleet availability for those turbines that are under Nordex service of more than 98% of operation. Just recently, we were awarded by the Wind Power Monthly organization that the N117 2.4 is the wind turbine of the year due to its clever use of technology innovation, due to the product market impact and relevance for specifically low wind sites, fitness for purpose, reliability record, and grid connectivity, as well as installation and upkeep. So far, we have order intakes of three-digit numbers of this N117 2.4 turbine, which is a very successful model, specifically for very low wind sites. Just recently also introduced into the market is the next generation, the Generation Delta. Generation Delta turbines are marked by their 3,000 plus kilowatt rating, also following the evolutionary process of adapting rotor sizes and introducing new rotor sizes into light wind segments. Talking about the market, Nordex is very successful in Turkey. Today we are having a market share of 25%, and as you can see here, we have installed, or in the pipeline to be installed, over 422 units, which accounts for 10 gigawatts of rated capacity. Very successful track record, and it's been driven forward by a very successful portfolio. The portfolio basically derived from the Generation Gamma, which you can see here. Generation Gamma defined by the N90 for very strong wind sites, the N100 for moderate wind sites, and the N117 for light wind sites. Introducing the Generation Delta turbines, we were able to provide over 30% more annual energy production at the same site by offering a new turbine type into strong wind sites. That is the N100 3.3 megawatt, which comes also with 3 different hub heights. On the moderate wind regime, we are now able to offer an N117 3.0, also offering an increase in energy production of more than 30% at the same wind regime, and introducing a new turbine just recently, the N131 3000, which gives our customers an increased energy production of over 25% at the same wind location. The N131, with a rotor diameter of 131 meters and a rated power of 3000 kilowatts, is available up for serial production in mid of 2015. Coming to the relevant factors and the success factors of the Nordex portfolio. You can see here in a different view the two generations that are currently our active product portfolio. As you can see here, it's quite clearly that we have built our new turbines on common grounds, shared and proven components, and adapting, for instance, rotor sizes in order to harvest the good reputation and the good track record and the certification and the proven power curves and noise qualification also for our new moderate wind side module, the N117 3.0 at the IEC 2.2A wind side, offering, for instance, compared to an N100, plus 37% more swept area in harvesting the wind at a given site. Basically, comparing the wind, the rotor blade is defined as the component that is the key trigger for efficiency on a turbine. The rotor blade is defined, designed, developed, produced, tested, installed by Nordex, one of the core competence within Nordex. The first Nordex wind turbine blade was targeted towards an 80 back a couple of years ago now. And here you see, for instance, the tremendous effort and also lever that we put into the N117 by applying new and modern material technology. So on this chart you see that by applying new materials like carbon fiber composites into the main girder of the rotor blade, we were able to even decrease the total weight of the turbine rotor, which accounts for loads and also in the end for the overall leverage cost of energy, to be even less here for the NR58.5 blade, which is mounted on N117 2.4 turbines and N117 3.0 turbines over the N100 2.5 turbines or N100 3.3 turbines. So basically the main girder accounts now for all new blades of 18% of the whole blade weight. And just to illustrate what we were talking about here, here you see the inner structure of a blade, a turbine blade on the left side of an N100 turbine, the NR50, built of glass fiber reinforced plastics, mainly with main girders, trailing edge shear webs, trailing edge girders, and two shells. On the right side you see the new design of the N117 turbine, where we have replaced the main girders by girders made from carbon fiber composites, and achieving a significant weight reduction, a significant reduction of loads into the turbine structure, and therefore a significant reduction into the cost of energy for our customers. Basically, the design of the rotor blade has been proven in different areas. It has been certified in terms of the power quality, it has been certified in terms of the noise emission, it has been certified in terms of the power curve. The power curve verification was done according IEC 61400-12 by WindConsult, and it has been proven and certified for the correct lightning protection, and certified also for 61400-24 class 1 lightning protection requirements. Basically, not only the girder material, but also the outer shell was improved for two key performance factors that are driven by the turbine blade. For first, the average energy production as to the yield of the turbines. As you can see here on the right side, we have moved the root section towards more towards the nacelle to harvest more, let's say, wind in that section in order to improve the energy production. So the max chord moved further towards the root. And for sound and load optimization, you can see here from an evolutionary perspective, the NR50, NR50 8.5, and the NR65.5 for the N31 3000 and 131 3000 moved even to a more slender and slimmer design on the blade itself, which accounts for an even lower noise emission. Very important for those sites that are close to housings. Specifically, the low wind sites are not so far out, and this is one of the unique selling propositions here for the N131 3000 with a very low noise emission. It also accounts for the load of the turbine, so we were able to keep the key structural elements from the platform by applying the new aerodynamic behavior of these new blades. So basically the blade is the key component to drive energy production, to drive down sound power, to drive efficiency, and also to drive time to market, as the blade is looking at the development process, the longest lead time item when we are talking about new configurations, new turbine setup. But the blade is also the first component that hits the wind as our fuel and our motor, and drives our motor very efficiently. The blade, as well as all other significant and important components, are undergoing a very intense in-house but also external tests. The test facilities that we have in-house comprise of yaw system tests, pitch bearing tests, the rotor blade test bench, pitch system tests, dust and climatic chambers that we have in-house, and profound vibration tests. But we are also in dialogue with our sub-suppliers, do external tests at our suppliers, external tests at test facilities, but also having an eye on the fleet in the field, and are doing numerous measurements campaigns in the field to prove and to provide the most efficient turbines for all wind regimes. Here a small impression on how this blade test functions.
Here, rotor blades of up to 65 meters in length can be put through both static and dynamic tests. In just 6 months, we simulate the load on the blade during its lifetime of around 20 years. For Nordex, as a pioneer in the wind industry, it's crucial that we maintain our lead in technical skills in the future too. That's why we intend to resolutely continue extending our test centre.
as you can see, we pay particularly attention to tests and proven technology and use components that are undergoing extensive tests in our laboratories, but also in the field and at our sub-suppliers. Basically, looking back at the Turkish market and looking forward toward the Turkish market, we are partnering with a local blade supplier. TPI is one of the leading provider of composite solutions to the transport and military vehicle market and also provides into the wind turbine market with a focus on solid growth, a long-term partnership, and major industry players are partners with TPI already. TPI has factories in US, Mexico, China, and also in Turkey. Nordex is partnering in terms of building these blades locally. The NR 58.5 blade for the N117 2.4, but also for the N117 3.0 turbines that are, as we speak, currently installed in Turkey. Basically, TPI Turkey started in March 2012 as a joint venture with Alke Construction. It currently has 450 employees, but ramping up towards 1,000 employees, emphasizing that Nordex is investing and also ensuring that local workplace has been long-term secured. The TPI is also has also achieved the ISO 9001 certificate, and in the preparation of producing the NR 58.5 blade, there was an extensive shop floor approval with TPI, ensuring that identical production processes and high standards are met also for TPI as a product, as a blade manufacturer that is supporting the Turkish market, but also providing blades on a global setup. We made sure that during the ramp-up of the production, we had 100% quality assurance at the site, and the production personnel, an exchange program with our colleagues from Nordex in Germany, where we have also a blade production facility. So all in all, a very nice ramp-up, and we see already first projects being erected with these Turkey-made plates as we speak. So basically supporting the new feed-in tariff that was talked about throughout the day, where the basic feed-in was or is 7.3 euro cents per kilowatt hour, but then leveraging on incentives by local content of blades and turbine towers. Turbine towers are already produced locally for all Nordex turbines, so that all in all we can ensure that our customers are benefiting from plus 90% more feed-in tariff for the first 5 years, and this is granted right now up to the year 2020. Basically, in conclusion, Nordex is a competent partner with a long track record and high market share in Turkey. Nordex has a wide product range and superior technology with high quality standards and many tests, and all key components are certified according to the IEC standards. And Nordex provides with its supplier TPI a strong partner to fulfill the local content requirements. So if you bear with me some more minutes, we have talked about a lot of dry topics here, documents and figures. I'd like to bring you closer to a wind park and the work that has been done at a wind park when turbines are being erected. So basically here a small video also from the field. So thank you very much for your attention. If there are any questions, I will leave that with the Q&A session. Thank you very much.
Thank you, Mr. Baer. Mr. Baer'e teşekkür ediyorum.
Thank you, Mr. Bayer, for this presentation. This summer in the Hamburg Fair, I had the chance to see the facilities of Nordex in Germany. It was absolutely impressive, I have to say. And I'd like to thank you on behalf of my colleagues for showing us your kind regard and respect when we were there. Also, I hope that we're going to continue our cooperation with rotor blades and also girders and other areas. I hope we'll be able to do that in the long term, because when we ask you or your company what can be done in the future about this area, especially such an investment to take place in Turkey is very viable, and obviously the yearly around 100 megawatts of demand should always be there for them to invest in the country. So on a company level, I believe that it's not going to be a very big problem when industry keeps growing in Turkey. So I would like to tell you that, all right, come to Turkey with our local companies and also make use of the support that the Turkey is actually giving now with regard to legislation. So that's my invitation, if you don't mind. Now it's Yunus Işık's turn. Well, we have the same surname with him, so I will give him maybe extra 1 or 2 minutes, or maybe not. We'll see. 15 minutes, and try to be in time. Try to finish on time, if you will. Thank you. We have to free up this room before 6:30 because there's going to be a big reception, as you know. So thank you for being here. I'd like to thank all the participants and all the chairpersons, all the stakeholders who are here and who bear with us for till this time of the day. Our subject is going to mainly focus on technology after touching upon what's happening in the market. I will not try to bore you, and I'll try to finish as early as possible. We're going to look at 5 main items about the market, and we're going to share what we think about the market. So where were we? Where are we now? What's our journey, and where's our journey taking us? I'll give you basic information about the company, and I will talk about the innovative technologies we use in the turbines preferred by Enercon. We'll also talk about the reliable service and the reliable service that we support, and also we're going to talk about a basic conclusion towards the end without making it go too long, and we'll have a brief video to accompany our presentation. Enercon is a German company. Its name is derived from energy converter, and its installed capacity is over 36 gigawatts in the globe. Its production area is equal to 112 football fields, and all the production is carried out in these in-house. And Enercon is active in 32 countries, and 8 of them have production facilities, of which Turkey is one of them. And also for blade and also tower factories, it contributes partially to the production in Turkey. Its service stations are more than 300 worldwide, and mobilization and also service and support and all the logistics support is acquired through its own personnel, and its export countries are about 32 or 33 actually right now, and it's still active in these countries. As I mentioned, in Turkey we have a factory that produces blades and towers. So as mentioned before, these facilities have been active since 2002. We supply the market with steel tower and also the typical normal tower, and also concrete tower, I mean. When we look at the 2013 targets, if our target is 2,000 megawatts of installation every year, then we need to take into account the ideas of the investors and producers, and it's important that the sector doesn't lose its motivation. So the producers should keep in touch with the investors and the people of legislation, so to speak, so that there's no problem. The renewable energy keeps increasing, and obviously the wind energy is also increasing, and this shows the rate of wind, and it shows that its growth was over fivefold. And in parallel to that, let's see what's the situation in Europe, market shares in Europe, and we see the numbers of installed capacity and cumulative capacity at the end of 2013. And in 2013, if we're looking for a feasibility report and if we want to turn that into practice, obviously the manufacturers in the sector in Turkey must be given the chance to do so. Enercon has the leading share of market in Europe, and no outsource is used, and all the production is made in its own factories. As for turbine and installed capacity, Enercon has the highest stake. And when we look at the global development, they are in the top 3 or top 4 of the world. When we look at the market shares of last year, and we see the rates of development globally, and when we look at the installed power capacity according to countries, we see that in Turkey the rates are about 946 megawatts. And at the end of the year, with our ongoing projects, we will hopefully go over the borderline of 1 gigabyte. The main item of today's presentation is the technologies, and before talking about that, I'd like to talk about the technologies used by Enercon in the equipments. Our turbines are divided into 3 product categories, as you saw. So, in the Enercon technology, and when we look at the designs that make Enercon, so to speak, the generation and conversion have been split into 2 parts, and they have become independent of each other. The main reason for that is the turbines' adaptability to the grid and to maximize that. So Enercon in that field, especially for electricity generation side, we see that it is below the base of the. It is different than the conversion side, which is towards the base of the windmill. So obviously the quality of electricity targeted by the company is achieved by doing that. And one of the advantages of Enercon is that it adopts the direct drive system. What is direct drive? It transfers the wind directly to the generator, and this system has some advantages such as reduced drivetrain losses and also achieving higher reliability due to fewer rotating components, and also as there's no that there's a reduced vibration of the nacelle and the noise emission is lower, and it requires low stable operating temperatures. And since Enercon's been established, except the first few turbines that have been generated, Since 1993, the direct drive system has been adopted, and in the sector, looking at our 30 years of experience, and considering that we have turbines that have been active for more than 30 years, this is a technology that has proven itself. And looking at the new turbine technologies, they also have adapted, or they're adapting the direct drive system, and the R&D focus is generally on this side. And we look at Enercon, all the equipment is presented within the turbine. It has been totally isolated, and the protect is totally the turbine is totally protected from water. And looking at the technical characteristics or advantages, we talked about this before, and this is a more detailistic scheme. We see that in the Enercon turbines, when the generation takes place, the anaerobic generator is decoupled from the grid, and this DC electricity through the inverters are provided against voltage and frequency fluctuations. So you're always on the side that actually directs and manages electricity. So obviously, apart from that, the blade technology and the blade adapting technology, Enercon has adopted a wide flange, and the reason for that is to scatter the load in a better way. And obviously, this way, loads are coming out of the blade in a non-uniform manner. So then the loads taken from the rotors or blades are uniformly distributed towards pitch bearing, or on the way to pitch bearing. So adapters are very important for that. And also, as the blades can self-adjust their angle, then it has to optimize this load very carefully. So this adapter structure is utilized for that reason. And when we look at the rotor blades, Enercon has a different structure. And when we look at the advantages of the design of Enercon, we see that there's a higher efficiency due to the modified blade design, and also we see that there's less noise emission because of the optimized blade tips. So we see the difference of the Enercon design from the conventional design on the right side, and also we see on the bottom left the comparison of power curve measurements. Also a spoiler, or what we call spoiler, has been designed, which paves the way for a higher sweeping of the efficiency so that the electricity output is better. As you see from this graph here, this change in the blade increases the efficiency of energy about 8 to 12%. So this is unique to Enercon, and you can't find this in other turbines. And also the nacelle of the turbine, as you see on the bottom right, has an ellipsoid structure or shape. The reason for that, the basic reason for that, is when you position the turbines aerodynamically, turbines have a certain effect on them. So behind the turbine they cause a turbulence. To minimize this turbulence, we have adopted this design. And when you're devising a wind farm, obviously turbines can also be located very closely to each other based on this design. And also, looking at the new rotor blade design, the blade tips have now been optimized to lower noise emission, and it increases the power output by doing that. So that's the old shape and that's the new shape. So by using these tips, the turbulences can be eliminated in the rotor plane, and this obviously shows, or consequently shows, that the entire length of the blade is utilized without losing energy because of the turbulences on the edge of the blade, as we have mentioned before. Because the more you make use of the wind, the more electricity generated. And also for noise emission, it's quite important. And also for minimizing the turbulence, it's also very important, as we said. So looking at the picture on the right, a similar structure is utilized in the planes, and that is to minimize the turbulence and the noise emission. Especially if you have been on the Boeing planes, you actually see that. It's the same logic actually. So there's a lightning protection system in the blade. It covers the blade all over, and over the flanges there's a ring towards the end, by which we call the lightning protection ring. So when lightning strikes on the turbine, this is done so that the turbine isn't damaged, and it's a standardized system. Also, Enercon has a de-icing system that is obviously used against icing when the atmosphere is humid and the temperature is about -2 to -4 degrees Celsius. So, as there's a distinct risk of icing on the wind turbines, causing a distinct unbalance of rotor blades, and because of that, the electricity output or generation output is lower, and this can obviously cause in many more serious results. For nice pieces can also fly or fall down in a logical radius around the turbine. So to overcome these risks, there's a rotor blade de-icing system, and when the turbine stops and when there is no wind, you can do this kind of heating, but when the turbine is actively turned on, you can obviously activate this heating system. Looking at the grid integration, there are some options with regard to the electricity side, and for reactive power and for voltage and frequency, there are some parameters that need to be controlled, and obviously what the grid wants with regard to these levels is obviously important. So there are some options in Enercon to supply this. Especially what distincts or distinguishes Enercon is what we call the fault right through. Wind turbines must be able to remain connected according to the voltage dips and durations. So the Enercon solution is that all the wind turbines of Enercon are able to stay connected should there be any faulty conditions, even at zero voltage level, up from 0 to 5 seconds. So obviously it's obviously targeting to minimize the risk of trouble in the Enercon wind turbines. Obviously this solution is or can be spent in a reactionary way, which was obviously produced for active manner. So the maintenance and trouble call for the turbine is much easier to sort out. As I mentioned, these are the options. Turbines can be supplied with many options that are required by the grid. So a wide reactive power range can be taken in, or a fault right-through capability with dynamic reactive current injections, also a steady reaction to power dips, and also people from the sector will know that
standardını sağlayabilmek için
to make sure, to ensure the facts capabilities,
olabilmeniz için
you need to be very flexible on this standard. There are some technologies that you need to utilize, and Enercon in this field with regard to power electronics has taken some serious strides and has a distinct level of experience and knowledge.
evet bahsettiğim özellikleri tabii
I think we better sum up.
şebeke bazında
Looking at the grid
sapmalar
and deviations in the grid, let's say,
fan bazındaki sapmaların önüne geçmek ve
need to be
elindeki yazılımı
stopped. So you need to have reactive power and voltage controls. These options can be integrated,
bir örneği var.
and this is an example here.
Haberleşme sisteminden biraz söz edelim.
I'd like to talk about the communication system, the SCADA system.
Çevre birimlerle haberleşmesi, şebeke işletim
So you see how the communication network is established between the SCADA server to customer, grid operator, and the service. So
sunulması zorunlu olan SCADA'ya ek olarak bir takım opsiyonlar.
in addition to SCADA, there are also some other options
Burada amaç şebeke işletmecisi
that you need for better communication. So the key thing is that the grid operator
istediği güce hükmetmesini kolaylaştırmak.
can
Aktif
get the and can totally
sağlayabilmek için
reign the
opsiyonlar sunmak.
power options, and these options are
Bunlar neler?
presented by Enercon. What are these options?
RTU,
We have RTU interface, RTU control. These are the interfaces,
birimler.
and we have FCUs. Okay, what do we use these for?
İstiyorsa bütün bu standardı
Whichever standard is required by the grid is supported by these hardware and softwares. A general overview.
bir özelliğinden daha
Another important thing before I finish is
aktif.
the Enercon storm control.
Bu konuda da Enercon
Enercon
rüzgar hızını
wind turbines do not switch off at the typical
bir takım
cutout wind speed, but keep adapting their power generation or power output based on the wind. So
böyle bir durumda kanal
the key advantage for this is obviously maintaining a strong protection against potential storm damage, and obviously, as you see on the graph, the power, despite these changes of wind, is continuously kept under control. When we look at the towers, our highest is about 149 meters long, and looking at the current platforms can vary from E44 to E66 to E115, can be established as or presented as the turbine platforms. Our turbines are generally certified as Class 1A, Class 2A, so they are obviously adaptable to most fields. So when the turbines are manufactured, the ISCC standards are taken into account without getting away or getting derailed from quality. So all our turbines can be adapted to Class 1 and Class 2 environments.
çeşitli türbinlerden söz etmiştim.
We talked about turbines, E82, E92,
E115,
E115, and E126. That's our biggest turbine. That's how they go. I'm skipping these product slides so to speed up. I'd like to talk about one last thing. This is taken from the nature. You know, when owls go hunting at night and they approach their huntee very silently, so the turbine's noise was usually a big problem. So the noise reduction can be supplied at the trailing edge, and obviously this will help a decrement of turbulences. So if there is a serious emission of noise, then this serration technique can also be utilized. And with regard to transport, especially transporting bigger turbines is difficult. There are some optimizations in this area. The blades can be carried in two pieces. like a muscle shell, and obviously the divided blade gives us a logistical advantage during the transportation, as you know that the turbine reaching out to the field without any problems is obviously one of the most problematic areas, so there are only small additional costs apart from the substructure. So this is the picture that was showing that. I'd like to talk about the service and maintenance a little bit. Enercon has partnership agreements, and in Turkey it has a history and track record of over 15 years. This obviously is a full warranty maintenance and service contract covering all the details, all materials, and other items that are given or required. And we look at the Turkey facts. The average rate of flown support is about 98%. 98%. This obviously can be possible with a very meticulously planned service infrastructure. What about the cost of the Enercon turbines? What about the components? When we look at these, we see that because there's no reductor group, and because there's no shaft or main bearing, they don't really have a maintenance time or lifetime. So Enercon turbine is designed to be long-term and can operate without any problems for 25 years. I'm about to finish now. Obviously, with regard to service, this is the world average, European average, statistically speaking. Enercon, there's a classification from 1, which is the best, and 5, which is the worst. So this was service survey done by BWE, and shows that the Enercon seems to have a service success which is over the standard. So it's not just purchasing the turbine, but it's also evaluating the turbine after the sales, and that should make the necessary decisions. So there's a very proven and robust design concept with Enercon. That's what we talked about, and we talked about innovations. We talked about fault right through, which is a standard feature that exceeds all requirements, minimizing deviations and other problems. And also we talked about flexible power support components. We talked about communication capabilities, and we also talked about Enercon Technologies providing solutions to meet the demanding Turkish Grid Act or Grid Code. And these are our projects in Turkey, by the way, these photos. The 3 biggest projects, Karaburun, Geycek, and Soma. A 5-minute long video. No time for that, okay. Thank you very much. And we hope that you continue your successful business. So we can't show that video because we need to leave the room at 6:30, so our last speaker will have only 12 minutes, unfortunately. Thank you. Now, thank you, Yunus, for your valuable contributions and your presentation. Our last presenter will be Mahir Tosun, coming from Siemens. He's sales manager. And good luck. Thank you, distinguished chairman. I'll have the last word, it seems. And let's go on from there. So, we're going to talk about a machine that is going to actually say the last word. Everybody has talked about the technologies. Today, I'm going to talk about novelties. The new Siemens device, SVT 33130. So, it's devised for Class 2 and Class 3. Siemens launched its own direct drive technology in 2009 and started to establish that in 2010.
Tabii ki bu
And we
gelişme
start to
devam
utilize
ediyor.
that, and this development keeps going on. And since 2006, establishing the first prototype, Siemens continued its own
Evet, rekabet
direct drive.
beraber dişli tutmuş
Yes, we
sistemler.
have direct drive, and we have the drive generators, quantum blade. We have direct drive and the other method as well. So when you look at the stats and data from the stats, from our offshore experience, we can statistically say that we have the highest rate of practicality. Looking at the local development, I'd like to tell you, dear deputy, as the workers in Siemens, about 4,000 people here, say that we may not be natives, but we are locals.
Türkiye'de bir mevcudiyetimiz
Because
var.
Siemens has been almost ever existence in Turkey for over 160 years. So, in a company that serves many countries, we are very proud to export to 60 countries from Turkey. Looking at our own technology, in 2009, Siemens presented its direct drive technology, and it kept evolving, and it's still evolving. In 2010, we provided the 113, SVT 113. Yes, we are obviously competing with the direct drive technology. So this actually shows that the same equipment, same carriage equipment, same team, it can also be outsourced. So on the field, there's no complex establishment or installation, and you don't need a private or specific equipment. We start with quantum bridge and direct drive, and it can be installed on the field. We continued with 2113, then the quantum blade that we use is a developed version of the integral blade. In 2011, we moved on to 30113. In 2012, we moved on to 30108, and the blade we used in that was identified as the blade which can get the most load in class 1. So this is the Siemens know-how. And when we bought the bonus company, with an R&D cost of 300 million euros, and ongoing 20 million euros every year, Siemens now are getting the results of this product. By the end of 2014, we now presented the 3.2 family, 3.2, 113, 108, and 101. In their own areas, class 1 and class 2, these give the best energy production. And the last word will be said by 3.3130. Both in class 2 and class 3, it will be very distinctive, and we're going to present that in 2016. The direct drive platform will continue to develop, and obviously with regard to SCADA and monitoring, looking at the references of direct drive technology in Siemens, we started in 2009, established 1.2 gigawatts, and we sold 2.4 gigawatts. So a total of 3.6 gigawatt direct drive technology has been approved in the market, which we continue to use it. So looking at the technicalities that give us the chance, so we talked about the new Siemens wind power benchmark, the SVT 33130. Looking at the technical data, all the turbine manufacturers obviously show some reference. So here, this is what we see. The IEC class is class 2A. When we look at the nominal power, it's 3,300 kilowatts. The rotor diameter is around 130 meters. And what we target is to produce wind power cheaper than the coal power. That's our target as Siemens. We're targeting the coal plants. We don't have any other opponents. So the direct drive technology brings obviously more load to be taken. to us. And we can obviously have our own direct drive technology, and we can obviously resist higher loads. So 16 gigawatts per hour, that's the annual output at 6.8 amperes, and the serial production will start as early as 2017. So if your field is available, you can reach 50 capacity factors if your area is available. The prototype will be tested in 2016, and as I said, the turbines will come into effect commercially in 2017. We keep talking about results, energy generation. The most important part of investment with regard to technology is its added value. So when we look at the design of the SWT130, Class 3 was the area when we maximized the output. So we made a brief comparison. We now have a device which increases the annual energy production between 10 to 19% across all wind speeds. So our limit is a capacity factor of 55-56. So that's the future for you. Now we need to talk about the main elements. How do we do that? We use less equipment, simple installation. So as we say, you don't need any specific equipment or crew to install it on site, and we have about 400 equipments that we have taken data from. I'm now speeding up a little bit. Unfortunately, I'm not going into the details of technology. All I have, because you are the commercial companies, I will need to give you the same time. But no. I'm going to speed up. No problems. I'm going to talk about some important issues. Yes, it was reinforced, but also it's now much more resistant to higher temperature. So this means that it gives the best performance in the most difficult wind or weather conditions. I'm going to talk about the additional options which complement the drive performance in the key markets. So ice detection and de-icing systems for an optimal performance is crucial. Obviously, de-icing and anti-icing aren't the same things, but our R&D is still working on anti-icing, and hopefully we can also come up with something about anti-icing. We have direct drive and also the advanced noise control capabilities. So devised and designed by Siemens, we now have the most efficient blades here which help us control the noise. So we are an electricity company, so we are targeted to be the best in electricity. We have full-scale frequency converter with reactive power at no wind. So plus 18 is not a problem for us, basically speaking. Another thing is that what we have launched is the flexible service package up to 20 years. So we can easily say that because of the trust of direct drive to us, we can offer you flexible service solutions up to 20 years. So what does this include? However packages, or whichever packages you want to do, you could do these packages. And for 20 years, for the design life of the turbine, we can offer you warranty support. This is very important for us. This is obviously, this shows our confidence in our technology. We didn't really talk about the tower programs in Turkey, but towards the northwest of Turkey, we know that there are some new projects that show the utilization of these areas, and We now have tower solutions of going from 85 to
Bu
185
alanda
meters,
teknolojiyle ilgili
35 meters, sorry.
özet olarak
And
son sözü söyleyecek makinenin 3.330
3.31130 will be
Class
in
1'de
class 2 and
sadece
class 2 will have the last word, I believe, and will be the future.
söyleyeyim. Onun bitirmek
And
istiyorum.
thank you for your patience. I
Ben
think I
çok
finished
teşekkür
on time.
ediyorum. Biraz hızlı oldu. Detaylar için
That was very fast, but
bana
you
gelebilirsiniz.
can see me for any kind of details you wish to see.
Mahir'e.
Thank you, Mahir.
Her üç
I'd like to thank
tabii ki kendi
all of our four presenters, and all the three presenters mentioned the
en iyi şekilde tanıtımı amacıyla sunumlar
advantages of their
teşekkür ediyoruz.
equipments. We'd like to thank them separately. So, as a result, whichever company produces whichever equipment, all the production should be easy to access, should be efficient, should be high quality, and
Yatırım maliyetinin ucuz
should have cheap investment costs, and obviously investors will take this into account. I would
özel sektör
like to thank all our participants
konuşan değerli başkanımız
who spoke on behalf of their companies and also who spoke on behalf of the state. We can maybe take one question because we're way out of time, so it's going to be a very clear question that requires a clear answer. Thank you.
Merhaba efendim.
Hello,
Cem Yalçın.
my name is Cem Yalçın from Nortel Energy
Son sözü de söylemek
Director.
istiyorum.
I'd like to say the last word on this.
Şimdi buradan söyleseydiniz.
Siz de kalırsa yarın söylersiniz.
We will have the time to say that tomorrow, so it's no big deal. So, up to 500 kilowatts, we have produced the local turbines, and
Meclis Enerji Komisyonu Başkanımızın tek şebekeye bağlı
as stated by the chair of our commission, the turbine he talked, which was in Bandırma,
hem de yönetim kurulu başında olan arkadaşım.
was there, so established by us. So these distinguished colleagues, they have mentioned very well these are technologies that we obviously take take by as example. As for local technology, you said that there's no local turbine production. I'd like to emphasize on that, and also for turbine practices under 1 megawatts. With regard to production of components, I think that's going to have a massive effect on Turkey, and that's what I'd like to talk about. Nortel right now can produce blades up to 50 meters of diameter using the infusion technique and epoxy rather, a local one, and
Sertifikası çerçevesini tamamlamış durumda.
it completed the framework of 61400 certificate, and also the SCADA system, hardware and software and all other materials have been completed and has now deserved to get the 11 cent local production. So I wanted to focus on 1 megawatt. We'll talk about this tomorrow, obviously. I'll be very brief. 1 megawatt of turbine can go up to altitude of 90 meters, but in the non-licensed group it's up to 60 meters. So Turkey, our target is to go to places that have 4 or 5 meters per second of wind speed and to produce nacelle turbines there. So our average can reach up to nominal power in about 7 or 8 seconds. So all our colleagues here and all the players of the market and should really collaborate, and obviously I would like to emphasize the importance of these technologies coming over to Turkey, because Turkey has the power to produce, and its difference is now closing. The gap between high technology and Turkey is now closing up. And when we started in 1991, we were at the 3 kilowatts level. Now in 10 years we came to 100 kilowatts, and 2 years later we arrived at 500 kilowatts. So technology is developing very rapidly in Turkey. Thinking about this potential in Turkey, obviously Siemens is here, and I would also like to invite other companies to invest in Turkey with regard to that. Thank you. Thank you.
özellikle o davete katıldığınız
And I have to say that I totally agree with your invitation.
söylemek isterim.
And also I'd like to tell you that in Turkey When I said that there was no local production, I was talking about the wind turbines that are now in operation, and this was published by when we look at the report coming from the Global Wind Agency, there is no local brand. That's what I was trying to say. Anacon, Nordex, Vestas, Siemens, Gamesa, Snowball, Astron, and Susan. So these are the market shares of Turkey. So obviously it may be wishful thinking, but we obviously need to see the Turkish local company or companies in this market share. So that was my good intentions, really. Obviously, we definitely appreciate all the works, all the efforts that you do, and this 1 megawatt limitation should be raised, and this would be much better for all investors. That's what I'm thinking. And obviously, we obviously need the smaller amounts, but obviously that the increase of that limitation will obviously give it a better chance for the other investors to take part in Turkey. Thank you. And thank you for giving us the information. So there are no other questions. Thank you for your patience. I'd like to declare the session closed. Good evening.
Sağ olun.